so I'd like to pivot next to continue the Personal Space Weather Station discussion. And this point, I'm going to bring Bill Engelke on from the University of Alabama to talk about the TanGerINE-SDR software itself, and it does say the word demo. So, Bill, I guess you will have the floor.
Okay, you got my audio?
Yes, I do, and we see you.
Okay, let me share this, and all right. So I'll just launch right into it because the time is short. Let's see, page down. All right, I'll give a quick review of the system architecture for people who are not familiar with the Personal Space Weather Station network. I'll go through that very fast because I think a lot of people have already seen this, so I won't belabor it. But if I go too fast, I'd encourage you to please download this presentation. It should be available on the Google Drive in case there's anything you want to take a look at in more detail. So something about the local host design, how the software ties into it. Since we don't have hardware available just yet, Scotty talked about that. Hardware is imminent, but the design of the software to control all this thing was so extensive, I felt it was very important to develop a simulator so that we could have make progress on the software while waiting for the hardware to be completed. And some example spectrograms taken using a simulator, and then a demo, kind of a limited demo, but it's what we have. All right, this is the Personal Space Weather Station Network logical architecture. On the left, you see the Tangerine software-defined radio, which has two major parts: the data engine that has the radio piece, the clock, and the FPGA that manages getting the signals digitized. And that little block to the right of it that you see is a local host. That is a small board computer, single board computer, such as a Raspberry Pi or Odroid N2, something of that type, that's designed to work in tandem with the data engine and used to control it. And then you can hang all kinds of different sensors off the local host, such as the magnetometer and other devices that we've discussed. That collects data, and then an internet connection takes you to the Space Weather Network. That is a database system that is being designed at University of Alabama that will allow you to sign into the system, establish an account, hook up your local host to it so that all of your data begins getting collected and then cross-referenced, and all data will be publicly available to anybody who needs to take a look at it. What is in the Tangerine itself? You've seen a lot on this, so I won't belabor it very much. Suffice it to say that on the left is the data engine piece. We'll have port 0 and port 1, two antenna connections, and the A to D converter to the FPGA, which is, you turn this on and off to begin collecting data. It's connected by a 3-port gigabit Ethernet switch to a local single board computer. So what I'll be showing is the software that runs on this single board computer. What is inside the single board computer? This is the software architecture for the local host right here on the right that you see. There is a web-based, browser-based kind of system that is the user interface. The idea is that you shouldn't have to do sophisticated engineering work, programming, editing of files, things like that, unless you really want to dive into the details. You should be able to use this thing without having to do that. That is used as a system, a web controller system running Flask and Flask WT forms. So that controls a Python 3 application, which is what is used to control the data engine. That app3 works together with this browser to control the data engine, tell the data engine what frequencies to select to turn on and off. When the data engine starts putting out high-speed data, this application forks off sub-processors that are written in C. You need to run closer to the hardware to be able to handle the high-speed data. This data is being able to do multiple things with it, such as save it in the digital RF format, which is optimized for controlling, rather, is recording spectrum data, decode FT8 and whisper, interface to GNU radio, and this is what's new since the last time I presented this, probably at the TAPR DCC, and handle remote fire hose data. What I call fire hose, there's a couple of different ways of running a fire hose, but this is just getting raw spectrum and saving it either to a local supercomputer, or if you're picking up just small pieces of it, sending it upstairs to the central control system at University of Alabama. So let's talk about how I simulated this thing. On the left, you see a Flex Radio 6600 with a GPS DO and a Windows PC running Smart SDR. This piece right here simulates the the radio piece. So it does the A to D conversion coming off of an antenna in my backyard. Happens to be hooked up to a DX Engineering vertical antenna at the moment, and a Windows PC running Smart SDR. This is necessary for setting the frequencies and other things like that. So that simulates the radio piece. Then there is an Odroid N2 microcomputer running a simulator package. In essence, this simulates what the FPGA in the Tangerine in the data engine will do. So that is, this simulates the data engine. Then over here, this is the local host. It's implemented on a Raspberry Pi 4B+. We've also tested it running on an Odroid N2, and that works just great because it's a little bit more powerful than the Raspberry Pi B+. And so this simulates this, well, this is the local host. And then finally over here, I'm running another simulation of, just so that I could get, well, here's the thing. This system over here doesn't do much of a job in running a Zoom session, especially when other things are running. So in order so that I could show this on this Zoom session, I have another box running VMware, running Ubuntu inside of a VMware session. So now bear in mind, you don't need all this to run the Tangerine, obviously. To run the Tangerine, all you need is this right here. I don't want anybody to misconstrue that. So this is just for the purposes of simulation. This is the front end. I'll show you an actual demo of this here in just a minute. This is a GNU radio layout that it's a flow graph that I've used to pick up data being spit out by the local host when it's collecting data, and show it on some waterfalls and stuff. This is a GNU radio output. Here you can see this is this morning as the sunrise was pushing pushing our frequency a little bit high. I haven't yet optimized the colors on this, so you'll be able to see these the sunrise Doppler shift a little bit better once I get the colors optimized. I've got some previous examples here where you can see the multi-modes that Steve Serwin was talking about occurring in the sunrise here and in the sunset. You see this occurring in both places. I have also applied this same system to the grape. I took the grape that OBJ John Gibbons sent me and applied some of the same software techniques using GNU radio and saving data in digital RF form, which it enables us to collect and store a complete spectrum information as opposed to a single frequency. So if you want to save more data, you want to use this kind of an approach. You can see where there's the sine wave shape that occurs in the frequency of WWV. Perhaps that's a transient ionospheric disturbance, or perhaps a solar flare. You see this. You can see some opposite information occurring, and on either side. So who knows what this is? So let me stop my share and bring up a different window here, so I can show you the run this demo here.
Right.
All right, so. All right, so you should see a screen of the Tangerine SDR. Is that visible?
That's right. Yep. 192, 168, 178. Yep.
Yes. This is connected to a running Tangerine local host in that architecture I showed a while ago with the simulation. So what you're now seeing is the Tangerine front end. Now, you can run this Tangerine front end on the local host itself. It has a web server, or you can run it from any other device in the network that has a connectivity through the network to it. So this is just to show you how you configure this thing. This is your main control panel. It's a one glance view of what's going on. At the moment, we're collecting FT8 data, whisper data, and the ring buffer. The ring buffer stores, the way it's designed, is it's designed to store up to, well, however much space you have, but typically a day's worth of data collected on your data collection system. And so when it gets a command from the central control, it will update, it will bring that, rather upload that data within the bookends. It will update that, it'll upload that data to the central control. The desire there is if our central science super user detects that there's some phenomena that's very important to catch, that person can command the system to upload everything for the past few hours up to a day's worth. Now, I talked about the ring buffer. That is the data collection part. It's kind of separate, logically separate from the FT8 and Whisper. We kind of use FT8 and Whisper as a propagation monitor where we show how many spots we've collected. At the moment, it looks like the most busy band is 20 meters. My Whisper data collector, well, it's collecting data okay, but the technique I'm using for decimating the data is so crude that most of the time this doesn't show anything. That will not be something you see with the Tangerine. This is a problem in my Tangerine simulator, the data engine simulator. So, but anyway, it does collect FT8 spots very well. So we can see that the hot band right now is 20 meters. Now, over here, the ring buffer, there is your data collection. You can start and stop this. And this is associated with this screen right here. This screen right here shows where is the ring buffer stored. We recommend that you use something like a Western Digital Purple hard drive for this, because this produces a tremendous amount of data, continuously reading and writing. So if you use something like just this micro SD card or an inexpensive hard drive, you wear it out in a matter of months. So we recommend using a video surveillance type hard drive here. FFT output path, that's something from the snapshotter mode. That takes a quick shot, a quick look at a spectrum of the band you're monitoring every about once a minute. And you can actually output that as a CSV and plot all that stuff into Excel if you like. You can control where the firehouse output path is if you want to store large amounts of local data and path for temporary files. So right now, we have just one channel set up, but it is possible to configure up to 16 channels of data collection, and you can independently set the frequency of each channel and which of the two antenna ports for each channel. You're able to set your user profile to indicate what node you're running, your call sign, other profile information, and a security token given to you from central control. We use that to make sure that everybody uploads to their own particular system. Let's see. This is the call sign and grid monitor that Scotty mentioned. You're able to specify up to 6 call signs or 6 grids. If the propagation monitoring system sees one of these call signs or grids show up in Whisper or FT8, it will send you an email. Here is how you set that up, where you're able to specify what SMTP server you want to use. I've got this set up so that I can upload to my own system, and what you can do is you can email it to one of those servers that translates it into a text message. So I can actually get a text message coming on my phone when a particular grid starts showing up in FT8 or Whisper. This is very, very interesting for people who like to chase DX. Here is how you set up your FT8 ports. I've got 2 of them running at the time. You set them off if you don't want to run a bunch of them. Same thing for Whisper. The plan is to be able to monitor up to 8. And so if we take a look here, right here, let's see. Oh, I've got to change the screen sharing on that, don't I? Hang on just a second. See if we can change the screen sharing on this to, I guess I have to, which one of these? Let's try this one. All right, so you should be able to see the moving spectrum here. What I'm displaying is, this is a wide quick view coming from GNU Radio. As you can see, we've got the local host is outputting data in UDP format, and I've got it transmitting it to the GNU Radio running inside this VMware workstation. So it comes into this UDP block, and then it goes through several processes, and then it gets displayed here on this waterfall. Now, this is kind of redundant in a way with the Flex Radio, because you can get a waterfall out of Smart SDR, but Smart SDR will not let you zoom in tight into sub-hertz levels of resolution. And this relative gain display down here is to allow you to try and pick your maximum and minimum frequency, rather maximum and minimum signal strength to try and optimize the display of this. You can see still a little bit of the Doppler shift from this morning's sunrise starting to scroll off the screen. This refreshes about once every 50 seconds. That's a function of the number of bins of output of the FFT that is done to show this. So anyway, this it's kind of hard to really go through all the different aspects of this due to time limitations, but I hope you get the idea of the Tangerine SDR, and we can see we can actually stop data collection. So at that point, this ring buffer indicator goes off, and you see that our data display has stopped. It's just waiting for more data to come in from the UDP system. Start it again, and this will start back up again. So that is an overview of the software for the local host and how you will use the Tangerine SDR coming out of the box. We're going to try and keep this up to date so you can download and install new versions as we apply, make improvements to it and fix any bugs that that turn up. Oh, I see we've got some traffic here on 30 meters. So you see this thing updates every minute or two to tell you what has happened on your different bands for propagation monitoring. So that is my presentation. Do we have some questions coming in from the audience?
I think so, and which has been tried to answer, but let me perhaps repeat it. It says, where does it say? So Ben with Willett says, did I understand correctly that with the orange SDR, you will be able to record data from 16 frequencies at the same time? I think by orange SDR, he means
the Tangerine.
Tangerine SDR.
Yeah, yeah. That is the objective. Now, because we don't have hardware yet, we can only hope until we have tested this. The plan is to be able to collect 16 different bands at the same time within the frequency range that the Tangerine can reach. I'm going to keep trying this until I keep adding load to this until it stops working. Right now, even on the simulator, it's running 1 channel of ring buffer and 2 channels of propagation monitoring. My goal is to get it to be able to run at least 8 channels of ring buffer data, 8 channels of FT8, and 8 channels of Whisper. Now, one thing about this is if you start running that many channels, you start needing to have a mighty wide-banded antenna. So I've been playing with a magnetic loop to get that wide-bandedness. So we shall see if our capacity gives us that. It's also possible to go with a higher performance data engine as well. There's nothing says that you have to run it on a single board computer. You can get a high-end desktop and install Ubuntu on it, and then this thing should work just like it does.
Thanks a lot, Bill. I'm going to need to move on, but
Yep.
you know, you can scroll through the chat. I think we've answered some of the questions. You might be able to add some to that.